In today's video, we are going to discuss the parts needed to demonstrate how logic circuit works. We need the power supply. This is 9 volts. You can use up to 12 volts. And then this is the breadboard power supply adapter. This is our breadboard. This is also some connecting wires, some LED, some resistors, and some push buttons. First, we are going to discuss about the breadboard. This breadboard uh, doesn't need solder, so we can make circuits here. We can interconnect circuits without soldering. So these hole here are called high points, and then this line represents that means that all the connections that will be connected on these tie points from this point up to this point will all be connected. Similar with this line with the red line, it denotes the positive terminal of the power supply. That's the side is labeled as positive, and all the tie points connected at these points from this to this are all connected. But these two tie points and row are not interconnected with each other. So this will be the power rails for the positive and the negative supply for our breadboard. And similarly here. And then these tie points here are interconnections for every connections that we'll be making. So for example, this tie point here connects to this one, and this one. So in one column, they are all connected, but it is not connected to the adjacent points. Meaning this point is connected all through this column, but it is not connected adjacent to this one, and that's not connected adjacent to this one too. So we can summarize that they are all connected in columns here, all connected in columns, but not connected in adjacent adjacent columns. Okay, so this is our breadboard, and we will discuss to you also about this breadboard power supply adapter. This can be used to power our breadboard. So we distribute power to our breadboard. Firstly, we have two power output terminals here. It is configured between 3.3 volts and 5 volts. So because we have also circuits that needs only 3.3 volts. So in this power adapter, we can configure it to be at 5 volts or to be at 3.3 volts. You can do that by just unplugging this short link, configuring it to 3.3 volts. You must put it like this. So this one will be the 3.3 volts output. And at this side, it is configured at 5 volts. So if you want to configure it at 3.3 volts also, similarly, you have to do the same as what I have done on the left side, just like that. And then you have a 3.3 volts here, and then 3.3 volts also here. But we will be dealing with 5 volts IC. So I will configure our board to be at 5 volts at both sides, just like that. This is the power input. We will be putting our power supply output terminal here, just like that. And then you have a power switch and power on and power off. This is the LED power indicator indicating that there is power coming in. And then we will use this one in the breadboard. So if you look at it, we have 4 legs here at both ends. So we can put this one on the breadboard like this, and then push it just like that. So after this, This will be our positive rail. This will be our negative rail, which is 5 volts. This is also our negative rail and positive rail on the lower side of the breadboard. So the power supply is just a source. You can just plug it on a convenient outlet and then put this one into this power in, just like that, and you can have the power on or off. Push button there to indicate that there is a power. So I will plug this one and I will show you how it operates like that. And if I turn the power on, you can see that the LED will be on, indicating that there are power running to our rails. And turn off. And so just for safety, before going to power out your work, you have to disconnect it first. And then these connecting wires are used to connect devices within our breadboard. Say, for example, if I want to connect the positive terminal here, like that, and then I will connect it to anywhere here, or just like that. So we can use to connect devices inside the breadboard. For example, I would like to make use of an LED. Remember, the LED has a polarity, which is indicated by the length of the legs. So in this one, the longer LEDs shall be connected to positive terminal always. And then the shorter one will be at the negative terminal. So if I'm going to let this LED light, I will push the longer LED lead here, as for example, like that. And then I will put connection to the positive terminal, and then I will put it on the negative, on the positive side of the LED, just like that. So if you were looking at it, this one will be connected here. Just remember, just a while ago, that the tie point will be connected here, will be on a column, but not adjacent. Okay, but then I will put a resistor, because if I run the 5 volts there without any limiting resistor on the LED, it will be burned out. So I'll put a resistor here, and then it shall be connected to ground. So anywhere within the blue line, it is the negative terminal. So like that. So if I power this on, current will flow from this point up to this point and will light up the LED. Okay, let's demonstrate how it works. So I will put the power here in my breadboard, and then if I turn this one on, the LED should light. Right. So turn it up. What will happen if I reverse the connection of this LED? If I put the other way around without following the right configuration, you will not be able to light the LED. See, you power that on, and there will be no power. There will be no light emitted by the LED because it is reversed connected. So that's what they call reverse bias. So it will not light. But if you follow the correct polarity, it will light. Okay, that's how to use the LED, the connecting wires, and the resistors. That's why we need this in demonstrating our logic circuits. But what about this push button, micro push button that we have? So in order to use this, it will remember that these legs shall be facing you like that, like this one. Okay, not like this one. It should be like this. So if you put it on the breadboard, say for example like that, remember it will be facing not like this, but it should be like this. Facing you like that, and then I will put connection here from the positive terminal, then going to the other leg of the switch, and then I will put again a LED. I will put the LED here. The positive side will be on here, like that. So what am I doing is that the power supply will run through this wire and will go to the terminal of the switch. If I push the switch, this terminal shall be connected and the current will flow all throughout the diode and the resistor. So do not forget the resistor. Got to put the resistor here like that and put it on the negative line. Okay. Our circuit is complete. So if I power this on, as long as I'm not pressing this button, there will be no light from the LED. So, but at the instant that I push this one, current will flow and the light will light. Oops. Uh, Wait. If you push this button, the current will flow from this wire to the LED and then will emit light. So, yeah, if I push it like that, the LED will light. Okay. So I hope you could remember the configuration for the switch. So now let's go and check for other items. This is the IC, so that will be for the next video. What I've shown you here is how to use the basic parts in order for us to simulate the basic logic circuits